This is chapter 1, Algebra, A-levels, pure maths 3. Yeah. So in chapter 1 we have 4 parts: a modulus function, factors of polynomial, what do you call that, partial fraction, as well as this binomial expansion. So now the first part is the modulus function, and now most of you already have some background for modulus function, what modulus function is all about. Just a quick one. So when we say modulus of x, we are actually interested in finding the magnitude of a number. For example, okay, maybe I just draw a simple number line for you, 0, 1, 2, 3. So when you talk about modulus of 3, the value is what? The magnitude is 3. If I go negative side, minus 1, minus 1, minus 3, the magnitude of negative 3 is also 3. So now when you have modulus x equals to 3, x can take how many possible answers? It can be negative, it can be positive. Yeah? So we normally write this as modulus x, we can define as x. It is x for x more than 0, and it is negative x for x less than 0. If you sketch a graph, originally the graph of y equals to x, it is a slanting line with a gradient of 1. Y equals x looks like this. Okay? So when you modulus a function, you are actually interested in finding the magnitude. So magnitude is always positive. So this part here, for the x value that's positive, when you modulus it, it's still a positive value. But for the x value that's negative, the moment you modulus it, it becomes positive. So the graph of modulus function is always in the form of V shape. Okay? So now we can extend this to other types of modulus function. For example, you can have let's say a classic example, fx equals to 2x minus 1 modulus. So when you break it up, you can write this as 2x minus 1 for x more than half. But by the way, how do you get half here? Half here is actually the x-intercept. If you let 2x minus 1 be 0, x will be half. And maybe I illustrate by using a graph here. So today, if I will sketch a graph of 2x minus 1, we know it has a gradient 2, y-intercept of negative 1. So you can actually draw this way downwards, higher gradient, intercept here at negative 1. Now your x-intercept is actually half. How do I get half? I let the x-axis, y is 0. Yeah, fx and y is the same. I let it be 0, I get x equals to half. Now the moment you modulus, what happens is that this part here is reflected upwards. So the graph actually goes like this, yeah, because all the negative values are now becomes positive, right? So it has a V shape here, and this graph on the right hand side, right, the line on the right hand side can be represented by 2x minus 1. The line on the left hand side, you actually get this line by putting a negative in front of the original function, because when it times this negative inside, what we are getting here is 1 minus 2x. That means we are actually getting a straight line with a gradient of negative 2 and y-intercept of 1. So you want, you can put the negative 2x minus 1. This is for x less than half. Okay, so then we move on to the transformation of graph. So a couple of things about modulus graph is that when the original function modulus x, we know it looks like this. So what happens if you put let's say I put number 2 here, a negative in front? Okay, one more time, negative in front. So when you put a negative in front, the entire graph, the V-shaped graph, is reflected on the x-axis, so it looks like a peak of a mountain, right? Now what happens if you put a 2 in front? Now actually there's no difference between putting 2 inside the modulus or 2 outside the modulus. They all do the same thing. It's still a V-shaped graph, but this time the V-shaped graph is actually sharper, if you like, a higher gradient compared to this. This gradient is 1, this gradient is 2. And what if I have a half? Let's say there's a half here, and I put a, like I said, inside or outside, it's the same thing. So it's actually broader, or the gradient is smaller or less steep. Right? Number 5. Now what happens if you put a modulus, then for example minus 1? So now we are taking this graph and we are shifting it to the right by 1. Now just so you know, it applies for quadratic, it applies for any function on transformation of graph. When you minus the x value, you're actually shifting the graph to the right by 1. Okay? Number 6, modulus x plus 1, you are shifting the graph to the left by 1. Okay, sorry, I don't have space. I'm going to 7, 8 over here. Number 7. What happens if I modulus x minus 1? Modulus x plus 3. So I'm going to take the original V-shaped graph and I shift it up by 3. And number 8, when you have modulus x minus 3, you are shifting it down by 3. Okay? So, but for exam purpose, normally for modulus graph, they don't test you a lot of complicated stuff. The standard graph they always like to test you is in this form, for example 2x minus 3. Right? So you already know how to draw this, right? Okay, let's make it a bit different, plus 3. So since I've shown you 2x minus 3, right? I hope you know this one means what? You're shifting the graph to the left by 3 over 2. This is your x-intercept. You let this be 0, you get negative 3 over 2. Modulus it, it's a V-shaped graph, like this. And when you sketch a graph, you always have to find the y-intercept. Now, y-intercept happens when x is 0. Mentally, we substitute 0 inside. Y should be modulus of 3, which is just 3. Okay? So that is enough. Yeah, you can look at my the book here. They've already written all this for you. What happens if you have you put a negative in front, or the translation x-axis, y-axis, and so on. Okay? Alright? So you shift to the left by 2. Guys, in Form 4 and 5, I'll draw a table of values for you guys. No need to draw table values. You guys are A-level student. We go straight to this. Shift to the left by 2. So the graph should look like this. Yeah. However, I need to include one more thing. This one. Axis 0. 0 plus. Do you know the one inside equals 0? If I let x is what? 4 over 3, right? Now 4 over 3 is your vertex. Yeah, guys, 4 over 3 is your vertex. So I shift to the right by 4 over 3. Do I move up or down? No. So we go 4 3 to the right. The graph, you can say the gradient is a bit higher, okay, because of the 3 in front. But if you don't draw sharper, it doesn't really matter. It doesn't really affect much. So this 4 3. Now my y-intercept at y-axis, x is 0. If I put 0 inside, your y is what? 4. Guys, sorry, I'm not going to write all the working. You don't need to write all this working. Yeah? At y-axis, x is 0. Y is modulus of 4, which is just 4. First thing you need to do, the first one, it doesn't really matter whether the x minus 3 or 3 minus x. The moment you modulus is the same. Yeah? It's the same. Shifting the graph to the left or to the right? To the right by 3. Yeah? So it's a V-shaped graph. You shift to the right by 3. There you go. This is 3. This is x. Your y-axis. At y-axis, x is 0. Put 0 inside. Still 3. How about this? 2x plus 5. It's narrower, and you shift to the right or left. Right or left? Left by negative. If you are not sure, we just let this be 0. Negative 5 over 2. So the graph should be to the left, negative 5 over 2. Okay, I'll just show your intercept here, 5 over 2. And if I want to find a y-intercept, guys, my y-intercept is put 0 inside, 5. Okay, simple. And we shift to right by 5, and then our modulus becomes a V shape. 3 means it's a sharp graph like this, right? So we know this is 5. Then you find the y-intercept. Okay. So in this case, how to find a y-intercept? We sub x with what? At y-axis, x is 0. 5 minus 0 is 5. 5 times 3 is 15. Okay, the second one. What do I do? At x-axis, at y-axis, x is 0. I put 0 inside. This is a, oh sorry guys, I think I need to move it up. Sorry, because otherwise the graph is too low. So this is an inverted modulus graph, because you can see there's a negative in front, and your intercept, your x-axis, at x-axis your y0, x is negative 1 over 4. So it is an inverted graph with negative 1 over 4. This is negative 1 over 4. This one is your intercept. Yes. Now who can help me? How to find this? At y-axis, x is 0, y is minus 1. Okay? So what do I do first? This one means shift to the right by 4, and it's upside down. So how do you find your y-intercept? At y-axis, x is 0. So put 0 inside, answer is negative 4. Okay, the second one. I shift to the left or right? Shift to the right, 703. And it's a V-shaped graph. Okay. So we can find this is 7/3. The y-intercept 14. Okay. Done some basic modulus in your lower form, right? Now, how do you find or solve modulus? Whenever you open up modulus, you have to put a negative and a positive, right? Bring over. X is what? 8 or 4. Okay. So the second one, 4x minus 3 is negative 5 or 5. Bring over. X is what? This is minus 2. X is negative half. 4x is 8, x is 2. Yeah. So x is minus 11 or 3. So 5 minus 2x. 5 minus 2x is negative 1 and positive 1. Bring over. 2x is 6, x is 3, 2x is 4, x is 2. Yes. Okay guys, for example number 4, now there are two ways to look at it. One is by using a drawing two modulus graph and find the intersection. Okay, maybe I show you the first method first. If you were to sketch the graph of modulus 3x minus 1, it should be a V-shaped graph. Okay, this, and this is negative positive 1/3. The second one is also a V-shaped graph, but the gradient is actually smaller. This gradient is high, is 3, this gradient is only 1. So it's a little bit flatter. This one will intercept at 4. Okay, maybe I draw it time, it's a bit hard to see one more time. So you have this graph, intercept 4, lower gradient. This is 4 and negative 4. This is higher gradient, but it intercepts here at 1, goes up this way. This is 1/3. So now, one way of looking at this is that we know that the solution for this equation can be found by finding the intersection between these two graphs. But remember, this graph of modulus x plus 4 actually has two parts to it. This is the positive part, this is the negative part. Like we can write x plus 4 is equals to x plus 4 for x greater than negative 4. For positive part, is x plus 4. For the one on the left, is actually negative x plus 4 for x less than negative 4. As for the graph of 3x minus 1 modulus, again it has two parts to it. For the positive side is the one more than 1/3, is 3x minus 1. The one less than it, we need to put a negative in front because it's a reflection. Before that, it's actually here. We reflect it up to algebraically to reflect this up. We put a negative in front, so it is this way. The gradient becomes negative, so this x less than negative 1/3. Positive 1/3. So, but you don't have to worry about so much detail about the rule. That means we take x plus 4, we solve it with x plus 4, also intercept with a positive. So, what we can do is we can solve them. Multiply inside, bring over, this will be 4x equals to negative 3. X is negative 3/4. Makes sense or not? This is negative 3/4, right? It's on the left hand side. Whereas the second one, bring over, this will be 5. This is 2x. X is 5/2. 5/2 is over here. Yeah, we can see that. Now, but we don't really need to do this actually, because if you can see that both are modulus, no matter how you draw it, one modulus like this, another one modulus like this, they're bound to intersect at 2 points. And we know that when you square something, there's a plus minus to it. So what we can do, instead of trying to like do this one by one, we can just square both sides. As in, x plus 4 square equals to 3x minus 1 square. Okay, this is actually what do you call it? Algebraic property, that is modulus of x, if I square it, the result is equals to x squared. So using this, we can say that 3x minus 1 square is the same as x plus 4 square. But rather than try to expand this, like a lot of people expand and bring over, factorize, I don't want you to do that. It's harder, it's longer. We know that a square minus b square can be factorized into a plus b, a minus b. So what I'll do is I transfer this over. Okay, for this time I'm going to write longer step for you, and we can put it together as a plus and a minus. Yeah, the minus you times inside 1 by 1. So let it be 0. So the result will be 4x plus 3 and 2x minus 5. It's a quadratic equation, right? And x is negative 304 and positive 5.2. So you don't have to draw this graph. Yeah, you don't have to draw this double modulus graph and find the intersection, which is so long. Yeah, so you can just solve it directly by squaring both sides, bring it over, factorize, and solve for x. Okay, so likewise the second one, I see double modulus, straight away you can square both sides, the left and the right. You bring it over. Okay, it's up to you. You want to bring this over also can. But guys, since you already know it's going to be 1 positive, 1 negative. Negative, I just change the sign. This positive becomes negative, negative becomes positive, right? And I put it together, this would be 3x plus 7. And the second one will be 7x plus 1, right? So your x is negative 7 over 3 and negative 1 over 7. Yeah, that's all. 2 answers. Okay, for self-test 4, yeah, we use the same method. Square the left and the right. Okay, but for me, maybe I'll bring this over. You can bring the other one over, so can, up to you. So I'm going to write x minus 3 minus half x and x minus 3 plus half x. It is okay to have a fraction because we can actually get rid of a fraction later. Right now we subtract this. This is half x minus 3 and 3 over 2x minus 3. You want, you can multiply by 2, so this is x minus 6. This would be 3x minus 6. So here x is either 6 or 6 over 3. 6 over 3 is 2. As for b, again I square the left and I square the right. But I can see that this x here is negative, so it's actually better to bring this over, right? So I can avoid having more negative. But if you bring this over, it's also okay. You can still get the same answer. This is a plus, and the second one is a minus. Okay, so this will be negative 8 minus 3x. Second one will be 9x plus 6. Right, so x is 8 over 3 negative 2 over 3. Yep, that's all. Basic stuff. Modulus section, what I do? X plus 7 between minus 4 and 4. We can do that straight away. But don't go square root, this is not square. Okay, second step, I minus 7 on the left, on the right. That's all. Second one, 2 plus 5x, modulus more than, less than negative 12, greater equals 12. Bring over, negative 14, x is less equals 14 over 5. Bring over, 10, x is greater equals to 2. Okay? Okay, for self-test 5, so what we can do is to open up the modulus. Every time you open up the modulus, there's always a plus minus. The negative one, we change the symbol. The positive one, we maintain the symbol, right? So here, if I transfer this over, x will be less equals to negative 5, x is greater equals to 11. That's all. But for me, right, you can use this relation that I mentioned earlier. If you have x modulus x less than, say, b, so x will be between negative b and b. So if I have x minus a less than b, when you open up modulus, you can straight away write negative b, positive b. Just bring the a over, that will do it. Now, so in this case, we can say 4x minus 5 is between negative 9 and 9. So here we plus both sides by 5. When you plus with 5, get negative 4. This will be 14, right? And if you divide, so for example 6, this is inequality involving two modulus. Again, I would prefer to square both sides. Yeah. If you were to solve it using graphical method, again I can explain to you the graphical method, but like I say, it's long. This one is modulus x plus 6, so that means it will intersect here and negative 6. This will be positive 6. This will be sharper because the gradient is higher. The gradient is 3, this gradient is 1. Sharper. The y-intercept at 8. It goes up like this. You know this intercept here and here. So this is 8 over 3. And I want the modulus x plus 6 to be below this modulus 3x minus 8. So again, we can think the positive side of this, right? It must be less than the negative side of this 3x minus 8. And the positive side of x plus 6 must also be less than the positive side of 3x minus 8. Yeah, positive side means this side, the right hand side. Okay, by the way, when I talk about positive side, I just want to be very clear that if you have y equals to 2x minus 3, the positive side is this. The moment you modulus, the left hand side, this is 3 over 2. This side is 2x minus 3. This is negative 2x minus 3. However, what if I change this to 3 minus 2x modulus? But so far, rarely that you test question like this. The positive side is actually the left hand side. Yeah, because the gradient is negative, right? And the negative side is the right hand side. Just take note that this thing exists. So I don't want you to think that the positive side should be the right hand side all the time, depending on the question. But so far in your A-level exam, most of the time they'll give you a positive gradient. So before you model this is usually a positive gradient. But in case it asks you negative gradient, the positive side is actually the left, the negative side is actually the right. Okay, let us just solve this. So this is negative 3x plus 8, bring over 4x less than 2, less than half. So that means that this is here, less than half. For anything less than half, the modulus of 6x plus x plus 6 is actually below the modulus 3x minus 8. Yeah? Here. And the second one you bring over, this will be 14 less than 2x, x more than 7. X more than 7 should be over here. Right? Okay? So, but again, I don't like to use graphical method, it's too long. Yeah? Squaring both sides will be much easier. Square the first. We square the second one. So, what do you want to do? Bring this over, bring this over. Again, actually, it doesn't really matter. So, I'm just going to bring this over here. So, it's minus 3x. Okay, put the positive ones first. Alright? And put the negative one. 3x minus becomes plus 8. That's equal to 0. So, this will be 4x minus 2 and 14 minus 2x. Okay. Alright. I think it's better to make this positive. Yeah. So I'm going to divide by 4. In fact, I'm going to divide by negative 4. Yeah. So this becomes 2x minus 1. When you divide by negative, you just divide by one of them, not both of them. So I want to make this positive, x minus 7. But whenever it times and divide negative, you switch the symbol. Right. Just take note. Because why I do that? Because most people are familiar with solving quadratic inequality by sketching a graph, right? So this graph has roots of 1 over 2 and 7. Now, come to think of it, if you transfer this over, then you would have avoided the negative altogether, correct? Because this 3x is bigger than 1. If you transfer this over, you don't have to times the negative, or divide the negative. No? So more than 0 is here. In here, remember, quadratic inequality, your form 5, form forward, or year annual, right? More than is here and here. So conclusion, x less than equals 1 over 2, x greater equals to 7. Yeah, notice I got the same answer, but I think I missed an equal sign here. I missed an equal sign here, can you see? So if you use this method, you still get the same answer. But this one you have to look at the graph, right? And this is easier, right? Okay, the next one, we square both sides, x plus 4 square. But think about these two, when you square it, I suggest we square them one by one, or you can square them like this. Yeah? So that I can transfer this over. This will be 1 negative, but this will be x minus 10. Less than 0 is underneath, is between 2 over 3 and 10. Right? That's the answer. Okay, now look at chapter 6. We square the left and the right. I transfer this over 5x minus 2 plus x and 5x minus 2 minus x less than 0. Okay, put it together. This will be 6x minus 2. This will be 4x minus 2. So for me, up to you. You want to divide by 4? Divide by 4. Divide by this one. Divide by 2. Divide by 2. Don't divide also can. We sketch a graph. The roots are 1 over 3, 1 over 2. Less than 0 means the region should be here. So x is between these two. Okay. For part B, again I will square the left, square the right. Okay, this will be 6x minus 3, bring over, plus x plus 1. The second one will be minus x minus 1. Now, when I transfer this over, this whole thing is greater equals 0. So let's put it together, 7x minus 2. This will be 5x minus 4. So the roots are 2 over 7, 4 over 5. So with that, more than is above, remember, you shade the region below. So your x value should be less equals to over 7, greater equals to 4 over 5. Alright, that's all. So for the next one, okay, now the next one is a little bit different. We cannot just square both sides. Why? You see, unlike a modulus, right? You see, a modulus graph, right? Let's say I have one modulus on the left, one modulus on the right. We know the graph, okay, maybe I put another number, let's say this 2x. We know the graph will intersect at 2 points. One like that, let's say second one, maybe I put like this, one like this. They will intersect at 2 points. Okay, no matter how I draw it, it will intersect at 2 points. So when I use squaring, I can solve it. I will get 2 answers. However, if one with modulus, one without modulus, it will not intersect at 2 points. You have a modulus like this, and the second graph may be like this. It depends. Sometimes they intersect at 1 point. Sometimes the graph may intersect at 2 points. So you cannot just square both sides, because squaring both sides means you're creating additional solution. Then you have to test one by one and see whether which one is valid, which one is not valid. So what we have to do, okay, remember, with one modulus, one without modulus, graphical method will be easier, right? Okay, so number one, let's sketch this graph. How does this graph look like? Don't have to draw a big graph, small graph will do. Modulus x plus 4 is like this, intersect at 4, yeah, negative 4 here. The second graph is y equals 2x. Yeah, this is modulus x plus 4. The second graph is y equals 2x. Now y equals 2x will be sharper, as in it has a higher gradient and it intersects the x-axis, y-axis at 0. So this line y equals 2x. Can you see it intersect here? Right? So, and I can see that it actually intersect with the right hand side, the positive side. So what we do is we take 2x more than x plus 4, bring over x more than 4. So we can see, just to verify, I draw this line for you. I want you to see this. This is 4, right? Okay. So I want the straight line here to be above the V-shaped graph. Which part it is above the V-shaped graph? From 4 onwards. Can you see? this part here, it is above the modulus graph, the V-shaped graph. Yeah, that's all. Okay. If you were to do the squaring, yeah, some people will go in square left and right. So what did they get? They get 4x squared greater than x squared plus what is this? 8x plus 16. Then they bring over 3x squared minus 8x minus 16 less than 0. And here you have how many solution? 48, 12 and 4, right? 12 and 4 minus and plus. So when I sketch my graph, I'll get this and this. Yes? So, but you need to double check. We don't know whether this is true or not. So we pick a number less than negative 4 over 3. Give me a number less than negative 4 over 3. Maybe we take negative 2. We let x equals to negative 2. You put inside 2, negative 2. You get 4, right? If I put negative 2 inside, what do I get? Negative 2 plus 4 is modulus of 2, which is 2, right? So can we say that 4, wait, yeah, I made a mistake here. Sorry, this is the multiplier, negative 4. Can we say that negative 4 is bigger than 2? No, right? That means I pick a number less than negative 4 over 3. Negative 4 over 3 is 1 over 3. For example, I take negative 2. I sub inside here. Negative 2 times 2 is negative 4. Can we say negative 4 is bigger than this now? No, right? So I don't like this method because after I do so long, right, there are 2 answers, right? Then I still have to test and see which one is valid, which one is not valid. So what I'll do is, if I see one is with modulus, one without modulus, straight away I sketch a graph. And you notice when I sketch a graph, I can see intersect with right hand side. So I take the positive side. The positive side means the one without negative. I just take x plus 4. Straight away I can solve this. I get the answer straight away. Isn't this faster? Yeah? Wonk, are you with me? Yeah? Okay. Now the second one. Let's draw. This is a modulus graph that passes through 2. It's a V shape. Passes through 2 like this. Okay. This is a slanting line graph that passes through positive 4 over 3. Sorry, it's a negative gradient. 4 over 3 should be somewhere here, right? Hello? 4 over 3. This intercept should be 2, this intercept should be 4. Now I can see that this straight line here now intersect with the negative side of this graph. Negative side of this graph means I put a minus here. X minus 2. Yes or no? Yeah? Okay, this negative I can times inside. And I rearrange it. 2x is now greater than negative 2. Did I make a mistake here? 2x greater than 2, sorry. X is greater than 1. Okay, see ya. I want the straight line to be above. I made a mistake here. No? I want the straight line to be above x minus 2. Yeah? Which side is above? Sorry, I want the straight line to be below the V shape graph. Below, right? Left hand is below, right? Can you see they intersect at 1 here? This is 1. Huh? Okay. The straight line is below the V shape graph from 1 onwards. 1 is here, right? This side onwards. Isn't this easier, this method? But notice, pay attention. Modulus on the left hand side is negative. So you're going to add a negative times inside. If they intersect with the right hand side, do I add a negative? No. Okay. First one. The first one is a V shape. Shape to the right. Okay. And this one will be 3 lah. Now you can see that this is 3, this is 3, right? This is your original graph of modulus x minus 3. Now where do you draw y for x? Y equals 4x has a gradient of 4. Is much higher, much sharper if you like, yeah, steeper, sorry. So this is y equals 4x. Now it actually intersects with the left hand side of x minus 3. So to solve this, we write 4x less than, the left hand side I must put a negative x minus 3. Yes, expand, bring over 5x less than 3, x is less than 305. Now, makes sense or not? I want this straight line to be below the V-shaped graph. Below V-shaped graph is here, less than 305. Okay, the on the left or on the right? This one, and this graph is 5 minus 2x. 5 minus 2x is the graph with the steeper gradient. Your y-intercept is 5. Your x-intercept is what? 5 over 2. Now, how do I know 5 over 2? I let this be 0. X is 5 over 2, right? Yeah? Okay, now you can see that it now intersect with the right hand side. Now, I know some people may wonder, will this ever intersect? No, because this one has a higher gradient. The graph should, I should probably draw a bit higher. It will not, they are diverging. Yeah, this one, it will not intersect with this line again. So, to find the point of intersection, I can see that it actually intersects with the right hand side, the positive side. So I don't have to put a negative. I just solve this. Bring over 3x less than 6, x less than 2. Okay.